Imagine yourself walking down a dark street. It's late. Shadows stretch out from lampposts. You hear footsteps behind you. Your heart starts to race. What's the first thought that pops into your head? Probably, someone's following me. It's a natural reaction, a primal instinct to explain the unknown with the simplest, most immediate possibility. But what if the explanation isn't that simple? What if those footsteps belong to someone just taking a late-night stroll, their path coincidentally intersecting with yours? Our brains crave simplicity, but the universe rarely obliges. This is where Occam's razor, a principle often touted as a beacon of reason, can sometimes lead us astray. Occam's razor, named after the 14th century philosopher William of Occam, states that given competing explanations for a phenomenon, the one with the fewest assumptions is usually correct. This principle has been a cornerstone of scientific methodology, providing a guiding light through the fog of complexity. It's a principle that has guided scientific inquiry for centuries, urging us to shave away unnecessary complexities and focus on the most straightforward explanations. By doing so, it has enabled scientists to make groundbreaking discoveries and advancements, from the laws of motion to the structure of DNA. And in many cases, it works brilliantly. Simplifying complex problems often leads to elegant solutions that are both effective and efficient. This approach has been instrumental in fields ranging from physics to medicine, where clarity and precision are paramount. It's why we no longer believe the sun revolves around the earth or that diseases are caused by bad smells. These misconceptions were debunked by applying Occam's razor, leading to a more accurate understanding of our world and the universe beyond. But like any sharp tool, Occam's razor can be misused. When wielded without care, it can cut too deeply, discarding valuable nuances and complexities that are essential for a true understanding. The problem arises when we mistake simplicity for truth. In our quest for easy answers, we may overlook the intricate details that hold the key to deeper insights. This can lead to oversimplified models and theories that fail to capture the full picture. The universe is a messy, complex place, and the simplest explanation isn't always the right one. Nature often operates through a web of interconnected factors, where each element plays a crucial role in the overall system. Sometimes the truth lurks beneath layers of interconnectedness, waiting to be unearthed by curiosity, not dismissed by a thirst for easy answers. It is in these layers that we find the richness and depth of reality, revealing the intricate tapestry of existence that defies simplistic explanations. By embracing complexity, we open ourselves to a more profound and accurate understanding of the world around us. One of the biggest pitfalls of Occam's razor is the illusion of objectivity. What seems simple to one person might seem incredibly complex to another. This is the subjective simplicity trap. Take UFO sightings, for example. Imagine three individuals observing the same unidentified flying object. A science fiction enthusiast might conclude it's an alien spacecraft. An astronomer might suggest it's a new type of drone or experimental aircraft. A meteorologist might see it as an unusual weather phenomenon, like a lenticular cloud. It's crucial to understand that none of these perspectives is inherently right or wrong. This highlights the importance of considering multiple viewpoints when analyzing such phenomena. Section 4. The simplest is likeliest myth, from geocentrism to heliocentrism. For centuries, the geocentric model of the universe with the Earth at its center reigned supreme. This model, deeply rooted in ancient Greek philosophy and later adopted by the Roman Catholic Church, was the cornerstone of astronomical thought. It was a simple, intuitive explanation that aligned with everyday observations. People could see the sun, moon, and stars moving across the sky, reinforcing the belief that Earth was the center of all celestial motion. The sun rose in the east and set in the west, seemingly orbiting our planet. This daily cycle was a powerful visual confirmation of the geocentric model. Occam's razor, the principle that the simplest explanation is usually the correct one, if applied superficially, would have supported this view. The geocentric model was straightforward and easy to understand. However, as astronomers gathered more data, the geocentric model began to crumble under the weight of its own complexities. The retrograde motion of planets, where they appeared to move backward in the sky, was particularly troublesome. To explain these anomalies, astronomers like Ptolemy introduced complex systems of epicycles, small circular orbits within larger circular orbits. These adjustments made the geocentric model increasingly convoluted. Planetary movements, inexplicable in the Earth-centered system, became elegantly clear when viewed from a heliocentric perspective, with the Sun at the center. Copernicus proposed this revolutionary idea, which simplified the understanding of celestial mechanics. Nicholas Copernicus, a Renaissance mathematician and astronomer, challenged the long-held geocentric view. His heliocentric model placed the Sun at the center of the universe, radically altering the course of astronomy. In his seminal work, De Revolutionibus Orbium Coelestium, Copernicus meticulously detailed his heliocentric theory, providing a more coherent explanation for the observed motions of celestial bodies. The shift from geocentrism to heliocentrism wasn't about finding a simpler explanation, it was about finding an explanation that better fit the observed facts, even if it meant embracing a more complex reality. This paradigm shift laid the groundwork for modern astronomy and fundamentally changed our understanding of the universe. Section 5. The oversimplification trap, the dinosaur extinction puzzle. The extinction of the dinosaurs is a tale often told through the lens of oversimplification. We often hear a simplified version of the story, one that fits neatly into a single narrative. A giant asteroid, we say, slammed into Earth, causing catastrophic climate change that wiped out these magnificent creatures. This dramatic event is often portrayed as the sole reason for the dinosaurs' demise. While the asteroid impact undoubtedly played a major role, to attribute this mass extinction event solely to a single cosmic bullseye is to fall into the oversimplification trap. This trap simplifies a complex web of events into a single, digestible story. The reality is far more nuanced. The extinction of the dinosaurs was not the result of a single event, but a series of interconnected factors that culminated in their downfall. The dinosaurs were already facing challenges before the impact, including volcanic eruptions that spewed climate-altering gases into the atmosphere and shifting continents that disrupted ecosystems. These volcanic activities released massive amounts of sulfur and carbon dioxide, leading to long-term climate changes. The asteroid was likely the final blow, but it landed on a world already teetering on the brink of ecological collapse. The ecosystems were already under stress from volcanic activity, changing sea levels and fluctuating temperatures. The asteroid impact exacerbated these conditions, leading to a rapid decline in the dinosaur population. Thus, the extinction of the dinosaurs was the result of a complex interplay of events. It was not just the asteroid, but a combination of factors that created a perfect storm, leading to one of the most significant extinction events in Earth's history. Understanding this complexity helps us appreciate the delicate balance of our planet's ecosystems and the multiple factors that can influence life on Earth. Section 6. The Emergent Complexity Challenge. Sometimes simple rules create complex behaviors. Look at a flock of birds. Each bird follows simple rules, but the flock's behavior is anything but simple. Occam's razor might make us miss the forest for the trees, or in this case, the flock for the birds. Emergent complexity is a phenomenon where simple interactions at a smaller scale give rise to intricate patterns and behaviors on a larger scale. This idea is not just limited to flocks of birds, it permeates various aspects of our world. From the formation of galaxies to the intricate dance of molecules in a cell, emergent complexity is a fundamental principle of nature. Consider the behavior of ants. Each ant follows basic rules based on local information, yet together they create sophisticated colonies with intricate tunnels and efficient resource distribution. This emergent behavior is not dictated by any single ant, but arises from the collective interactions of many individuals. In the human brain, billions of neurons communicate through simple electrical impulses. These basic interactions give rise to consciousness, emotions, and thoughts, an example of emergent complexity at its finest. The brain's complexity cannot be understood by examining individual neurons alone. It requires an appreciation of the network's intricate web of connections. The concept of emergent complexity challenges us to look beyond the surface and understand the deeper, interconnected systems that shape our world. It reminds us that the whole is often greater than the sum of its parts, and that simplicity at one level can lead to profound complexity at another. As we unravel the mysteries of our universe, acknowledging the role of emergent complexity can provide us with a more holistic and nuanced understanding of the forces that govern life and the cosmos. So, the next time you observe a flock of birds or ponder the workings of your own mind, remember that within simplicity lies the potential for extraordinary complexity. So, where does this leave us? Is Occam's razor useless? Not quite. It's still a handy tool, but we need to use it wisely. Here's the takeaway. Be aware of your biases. Your simple might be someone else's complex. Don't assume simple equals true. The universe is under no obligation to make sense to us. Use Occam's razor as a starting point, not an end point. It can guide us, but it shouldn't replace critical thinking or thorough investigation. And importantly, it should never be used to silence different viewpoints or opinions. Our complex world needs diverse perspectives. Next time you hear someone say, the simplest explanation is probably right, remember this video, share it with them. Let's sharpen our thinking by questioning our tools. And hey, next time you see a strange light in the sky, maybe it's not just swamp gas after all. Keep questioning, keep exploring, and never stop wondering. Until next time, stay curious.